Good afternoon. Welcome to the session, Network Architecture Transformation from LTE-Advanced to 5G, real-world experiences in evolving networks. We have 5 speakers and 5 presentations. The first presenter is John Baker from SVP, from Mavenir. He is SVP Business Development. Please, yep. Could you start?
Thanks. Okay, I think we've got a video somewhere, so play that first. Start with the video.
Reduce operating and capital expenses and make your network architecture more flexible with Cloud RAN from Mavenir. It's no secret that maintaining network architectures today is a monumental expense. Zoning, power consumption, backup power, and the sheer amount of hardware that requires time and manpower for maintenance continues to drive costs. And even though a network is designed to support the flow of traffic, nearly half of it sits idle during the day, while the other half struggles during peak hours. Not very efficient. But what if you could move network assets where you need them, when you need them? Better yet, what if you could pool resources within an open architecture and drive dynamic connectivity between control functions and radios? Cloud RAN from Mavenir redefines the network architecture by virtualizing network functions in data centers instead of on-site. Interfaces between the data centers and the radio using XRAN front haul allow the use of IP Ethernet transport and opens more possibilities for connectivity. Imagine your network running on secure, industry-standard computing engines with IP transport instead of expensive proprietary hardware. Imagine the cost savings and the possibilities. Instead of sending hundreds of workers out to manually upgrade a network with each new service deployment, Cloud RAN enables scalable, agile, and simple software updates. New services would be available instantly, saving operators up to 37% over a 5-year total cost of ownership. And computing resources can be shifted to the highest areas of data traffic virtually with resource sharing. For the cost of maintaining your current network architecture with closed-off proprietary hardware, Cloud RAN enables a software-defined service that speeds up time to market and gets you 5G ready. That's how we're transforming mobile network economics. Reduce operating and capital expenses now and prepare your network for future 5G innovation with Cloud RAN from Mavenir.
Could you put the presentation at the TV, please?
Yeah, good to see my slides. Well, whilst we're waiting for the slides to come up, that's sort of giving a view of, some of the things that, are going to change quite drastically, in the network builds over the next few years. We see the whole evolution of the RAN, and, this is the really last part that's been sort of hardware specific and turning to software platforms, open source software, open interfaces. And I think, as is in one of the slides earlier from China Mobile about, essentially white box radios. I think that's the next big step as we move to 5G. So have we got a clicker anywhere? Got a slide? Oh, there it is. Yeah, that's right. I'm trying to avoid PowerPoint, death by PowerPoint. So I've got a couple of slides on top of the video, but clearly the challenges as we see them, today, clearly the business model of how to make an operator profitable, and that's really where the focus is in terms of getting the best use of the bandwidth and increased profitability. Virtualization, given, since that, you can now get every element, apart from the radio itself, as a virtualized element to run on a COTS hardware platform. And, this is really going to drive the cost effectiveness, open source modules of software from ONAP and other forums, a lot of new standards bodies coming up and helping along with the virtualization of the elements in the 4G, 5G networks. coming out of that, the move to solve the latency problem and move essentially microservices to the edge, and really about disaggregation of the core network and how to move that core network onto compute platforms that are closer to the end user. A key to all of this, and Mavenir has been very open and driving some of the open interfaces such as XRAN, and talked about XRAN, ORAN, and also RANs, but there's plenty of interfaces out there. But making sure interfaces are open and commercially available to those that want to participate, to allow innovation to really drive some of the new products and new features in the network. And then, we talk about densification, and this is really about, how to get, as much capacity in a smaller place as possible. And, clearly use of microwave frequencies, millimeter wave frequencies, it allows us to do that. We sort of use the disadvantage of, minimal range with some of these frequency ranges, but, they really help achieve densification. So, you're going to see the benefits of the millimeter wave technology coming through. And then, how do you get spectral efficiency? How do you get capacity? How do you achieve, the densification without having to build new cell sites, and clearly work on, massive MIMO antennas, getting up to 64 by 64 type antenna array panels will allow some of that densification to take place. So, what does the network of the future look like? Today, you've got this distributed hardware, core hardware, data center, static backhaul, and it's really moving towards service functions, RAN software, NFVI cloud-based architecture, as we heard from Ericsson, and flexible transport systems with SDN. So we're moving into a very, very software-centric ecosystem. So, and then, like we'd heard about the EPC, the EPC really is sort of going to become the heart of this, but in a sense that the structure of an EPC is going to change drastically to sort of web scale type architecture that, very much based on, REST APIs and all of the things that we're used to from building websites. So you're going to see in terms of the ability to build, the new 5G core. With cloud compute, virtualization, cloud native, so no monolithic elements in there, building it stateless, so from a redundancy perspective and reliability perspective. And then last but not least, the ability to run services actually at the edge of the network. And then as the presentation from Ericsson about network slicing and DevOps ready, but, bringing together a lot of new web-based skills and resources to build 5G networks going forward to make them cost effective. So, that gives sort of an insight as sort of some of the things that we're seeing in terms of how this transition between 4G and 5G is really going to take place. And, some of this technology is here now, and some of it's coming down the pipe in the next year or so.
Thank you, John. The next presenter is Mr. Akira Matsunaga. He is acting chairman of Technical Committee of 5G-MF and KDDI. Please, Mr.
Yeah, thank you, Mr. Chairman, for your kind introduction, and good afternoon, ladies and gentlemen. Actually, this is my second appearance on the podium, and I'm very glad to be here once again. Yeah. So the session title today is the transformation from LTE-Advanced to 5G. So before going into the 5G network, I would like to address the 4G's role, okay, in the first place. Sorry. Yes. So this is the traffic forecast by Ericsson, and on a global basis. As you can see, the traffic on a global basis is growing steadily and is expected to grow further continuously at the CAGR of 42% beyond the year 2020. So in addition, you may notice from the left-hand side diagram that the Toward 2020, and even after 5G launch in the year 2020, 4G is expected to play the key role to accommodate mobile data traffic for some times. So in that sense, not only NR, new radio, but also 4G enhancement will be necessary and very important to accommodate traffic efficiently. And after 5G will appear in the market around 2020, 5G is going to be used to accommodate those mobile data traffic which may not accommodated by LTE more cost-effectively and efficiently. So from these factors, 4G and its enhancement will be important before 5G deployment and in each phase of 5G deployment, mainly from 3 reasons. The first one is that 4G is already deployed in many countries and serving to accommodate data traffic. And the frequency band in which 4G is now deployed has enables a wider coverage and desirable propagation or characteristics. And from capacity-wise, that's the third one. A close interwork between 4G and 5G will be necessary in every phase of 5G deployment, initially in NSA scenario as well as in standalone scenario later on. Okay. So this figure generally shows the illustrative relationship between frequency bands, area coverage, and use cases. And in this diagram, 28 gigahertz and 6 gigahertz, sub-6 gigahertz are the spectrum for 5G. The lower frequency bands, including LTE band, will be suitable for applications requiring wider coverage, including IoT, while peak data rate and the capacity will be lower than 5G. So 4G will complement 5G and work within 5G coverage. 4G will work as an anchor, and outside the 5G coverage, 4G will complement the 5G capacity. And the higher frequency bands, including millimeter wave, will provide speed and capacity, thus will be suitable for eMBB applications, including enhanced video communications, AR, VR, taking advantage of its wider spectrum. However, the coverage may be limited to spot areas as shown in this slide. So, and in higher frequency band like millimeter wave, not only downlink speed, but also the uplink speed will be improved. That will open up the possibility for new applications. Okay? And below 6 gigahertz, namely the 3.5 and 4.5 gigahertz spectrum is expected to be equipped with intermediate characteristic between millimeter wave and the LTE frequency band. So will be used for applications requiring higher peak data rate than 4G in a wider coverage than the millimeter wave. Thus, those frequency bands should be used in combination with the technology most efficient way. So this figure illustrates typical frequency band deployment scenarios in a variety of locations. What I'd like to stress here is that 5G will be deployed where requirement exists in urban and suburbs and rurals. For example, 5G will be used to accommodate the traffic which may not be accommodated by 4G, typically in dense urban area, in their busiest area, but not limited to that area, but also in suburbs and in the rural areas where requirement exists. For example, in a stadium, business partners areas, and where we need to promote 5G. Okay. So this slide shows an illustrative 5G roadmap in a chronological order. So In the left circle, around the year 2020, the initial commercial service will begin with EMBB expected based on NSA scenario, which will be practical continuing considering the 3GPP scheduled. And those initial services will employ, for example, video delivery in both uplink and downlink and VR and AR. And in the middle circle, later on, around the year 2022 or later, SL scenario using 5G core will be added to NSA architecture. Service requiring end-to-end low latency services will be enabled. And finally, going to the right circle, 5G-based IoT will be available after release 16 and the follow-on releases standard will be ready. So as for spectrum, NR will be deployed initially in 5G bands in both sub-6 and 28 gigahertz, and will be deployed in existing 4G bands as well in the future in order to take advantage of desirable propagation characteristics and coverage of existing band. So in this diagram, 4G will be used as an anchor of the NSA scenario in the initial deployment, and the close interwork between 4G and 5G will be important all through the 5G deployment, even if SA architecture will be adopted from users' perception point of view. And the WRC19 bands will be added around 2023 or later. So this is the final slide. So illustrates the roadmap considering 3GPP standardization and the frequency band arrangement schedule in Japan. So in Japan, 5G band will allocated by the end of fiscal year 2018.
Mr. Akira, please.
That is March 2019. Could you complete? Okay. Oh, sorry. Yeah, this is the final slide. Yes. Okay, so as I told you, the services will be added as the standard will be ready, and the spectrum will be added accordingly. So this concludes my presentation. Thank you.
Thank you. Thank you, Mr. Akira. The next presenter is Mr. Nivi Thadasina. He is Senior Director in Network Engineering Networks Division and at Samsung Electronics America. Please.
Yes, need Samsung slides, yeah. Yeah, perfect. Good evening. My name is Nivi Thadasina. I have the RAN product responsibilities for the US market. As part of that, I cover 5G, 4G, and pretty much 3G domain here in US. I have three parts to my presentation. First is on the how we would evolve from 4G to 5G. The next one is about RAN evolution. Then I'll wrap it up with our real-world experience in 5G and some of the work we have done here in States. I thought I was going to cover this slide, but I think the previous presenter from Ericsson, I think he did a great job covering all these options, I thought. So let me provide my views on this. So if you look at it on the top, I have three boxes. They're all non-standalone, option 3, option 7, and option 4. And now the question here is, when would you do option 3 versus option 7 versus option 4? And the primary reason, motivation for doing option 3 is that I already have an existing EPC core. I have a perfectly operating LTE system. And my coverage footprint is perfect. Now I'm introducing NR as part of, could be a millimeter wave, or a combination of millimeter wave or sub-6 gigahertz. But initially, the coverage would not be as prevalent as it would be for LTE. So in that case, is that what I would use is I would use LTE as my anchor, and then wherever I have NR coverage, the device would be smart enough to realize that there is an NR coverage, and automatically will hop in, and then will use a split bearer to provide services. Now the question is, what type of services would be offered through this? Obviously, for NR is that it's a primary services could be data services, and for LTE, obviously any type of real-time voice services, those probably would be anchored on LTE. Again, I mean, these are all depends on the coverage footprints. Another thing I've highlighted in each of these boxes is that progressively, as you go from left to right, you would reuse, the first one is reuse LTC EPC. Next is you replace it with a 5G core, and then on the right side is eventually you would use NR base station as an anchor. With a 5G core, now once you go transition to release 16, you can start to utilize all the new additional services that we've introduced up beyond the EMBM, the broadband services, the mobile broadband services as part of release 15. But in release 16 now, the other services are being introduced, so you can start utilizing these services. Now the option 4 is, when would you do option 4? Option 4 would make sense once NR coverage is as good as LTE or perhaps better than LTE. That's when you would switch the anchor over from LTE over to NR. Now the question here is that when would that happen? I think it all depends. Depends on how an operator would start to whether they would deploy everything on millimeter wave or would it be sub 6 gigahertz. It all depends on the deployment factors. At the bottom, I've tried to show you how progressively you may go from all the way from LTE on the left towards the just all 5G network. RAN evolution. There are a lot of parts to this. I mean, from the left to the right is, I mean, today you have a distributed network. You have a LTE stack, depending on how the split is this is how it's structured. From there, you would now we started to see the RAN evolving to more of a centralized. What that means, essentially, you're taking the baseband units, pulling it in a hotel. There are a lot of benefits associated with it. But this is already happening today. The next transition point from there on is the virtualization, the cloud RAN, and you would start to transition. May not be 100% of the RAN to begin with, but at least a portion of the RAN into the cloud, and you would still have certain LTE protocol structures today, or in the 5G case, you may still have certain types of lower layers, layer 1, layer 2, still may reside in a more of a traditional purpose-built hardware. Then the others are virtualized. But again, that's the initial phase. The next phase, obviously, is virtualization of the entire RAN, and that may involve that you may not have any purpose-built hardware. Everything would be sitting in a COTS platform. Another thing I try to highlight here is that in green color, please. If you notice, it's a frontal, and at the bottom I try to show in terms of XRAN. XRAN is an organization, a consortium created to develop, standardize, and it's an open initiative to take the lower part, which is the baseband and the radio units, and come up with an ideal split structure. At the same time, it's open. And there are a lot of benefits behind that, but I've tried to capture it here. From a Samsung standpoint, we have been doing trials for the last several years. We have taken a very phased approach. I mean, we are right now into our third generation, and then the one that would be commercially announced later part of this year would be our fourth generation equipment. What we have done is that starting back in 2015, 16, and 17, progressively we walked through in terms of proving of the technology, proving of millimeter wave, as well as trialing this technology in multiple cities across the United States in 2017. And this year, our focus would be on commercialization of 5G. I have 30 seconds left, so let me just go to the next slide. So let me wrap up here. I mean, this is our complete product portfolio. Clearly, we make all the way from end to end, all the way from chipsets to the core network. One thing I'd like to highlight here is that just last week, we received FCC certification for our products. That involves our access unit, which is our 5G base station. And then we have two CPE products. One is outdoor and indoor CPE. So all three products now has FCC certification. Thank you.
Thank you, Nivi. The next presenter is Mr. Butler. He is VP of Wireless Network Engineering, CommScope. Please.
Okay, thank you very much. I appreciate the opportunity to share a few thoughts with you. Could we roll the video now, please?
Everyone communicates. It's the essence of the human experience. But how we communicate is evolving. Technology is reshaping our lives, dramatically changing the way we live, the way we learn, the way we work, the way we play, and the way we thrive. The epicenter of this transformation is the communications network. It's our passion, the essential resource for today's marketplace of ideas, goals, and successes. The network has revolutionized modern communications. As the backbone of the internet and all wireless device usage, it has become the essential fabric of our digital lives. Networks have tremendous potential to connect us to each other, to help us communicate in new and interesting ways, and to advance human progress in nearly every aspect of our lives. From remote cell sites to massive sports arenas, from bustling universities to state-of-the-art data centers, we're passionate about connecting you to what and who you care about most, anywhere and everywhere. CommScope Solutions help make sure you have the bandwidth and capacity you need. We help network builders and operators enhance efficiency, speed network deployments, and simplify network migrations to new technologies. No matter where you work or play, today's professionals live a digital lifestyle that demands instant access and reliable convenience virtually anywhere on the planet. We're here to empower that lifestyle with world-class technology, because the world's most advanced networks rely on CommScope connectivity.
Okay, thank you for that. At CommScope, we provide the connectivity solutions, including RF path, that help move from 4G to 5G and provide the services needed. It's an exciting industry to be a part of. Think about the 1G brought us mobile voice, 2G made that more efficient, introduced data, 3G gave us mobile data, 4G brought us the internet, mobile internet, and now as we transition to 5G, we see a whole new set of use cases that the users are demanding. I just saw this morning an announcement from the University of Central Florida that they now have a fabric that can be controlled by your smartphone, so you can set the colors. So for clothing challenged people like me, if I put the wrong clothes on in the morning, I can just change the colors from my phone when I get to work. So it is an exciting industry to be a part of, and I think the key, some of the keys to evolving from 4G to 5G involve densification, virtualization, and optimization of the network. So for densification, we're talking about the deployment of small cells, so we can get more gigabytes or gigabits per second per square meter. And small cells are a key part of that. We've heard a lot about that. We've seen tens of thousands being deployed and in process, both in the US and throughout the world. Also, higher orders of sectorization are critical. There are networks in Asia, for example, where the majority of the sites have 6 or more sectors deployed. And the beauty of both small cells and higher orders of sectorization is that they also assist the other features that we've heard, MIMO, carrier aggregation, and higher orders of modulation. Virtualization is another key to this evolution. It's not just about more data or greater latency, but doing it at greater efficiency. Reduced CapEx, reduced OpEx has been a theme here. And virtualization is key to that, not only from the benefits of pooling equipment and sharing of physical resources, but also to open the interface. We've heard about XRAN and ORAN. I think this is absolutely critical to develop a 5G ecosystem that will drive the economics that everybody needs and expects. So in 4G, of course, CPRI was intended to be an open interface and wasn't truly open, but for 5G to succeed, we see that as a critical need. And then optimization, that includes not only the optimization of network KPIs through parameter adjustments, but also provisioning front haul, mid haul, and back haul bandwidths so that with the fiber connectivity to be and microwave connectivity to be able to supply the bandwidth needed not only today but tomorrow with 5G. So here, just show a quick view of small cells. I think that basically the low-hanging fruit for small cell deployments, the ugly deployments have already happened, and the municipalities are now more aware probably of what they can demand as far as deployments. We talk about these solutions in terms of where they end up on the pole. So at the base of the pole, we have concealment, could be a pole cab, as we show here, a monolithic cabinet and pole integrated. Mid-pole is usually specified by the municipality, and this is where we house the radio, the power and backhaul interface and so forth. It's important to have a good thermal design for the mid-pole concealment. And then top of pole is where we put the antennas and the RF path products such as interference mitigation filters and jumpers. The antennas themselves are key and central to the performance of any RF network, and even more so as we go to higher speeds. Whenever we talk about this evolution, convergence comes up. Convergence means different things to different people, but really at the foundation of it all, convergence means at least the sharing of the fiber assets between the wireline and the wireless networks. It could be, as shown here, where you have, say, GPON and LTE or 5G and DAS sharing a fiber through a wave division multiplexing solution, and then demux them on the other end of the circuit. It could also just carry the 5G transport over the GPON or NGPON2 network. And so this leverages the investment in the fiber network for the future. And finally, my final slide here, talk about the virtualization of the architecture. So here's a true cloud RF, if you will, cloud RAN solution. We're deploying this today on LTE. It is being trialed with 5-tonic because of the architecture. And basically, we have a user-centric cell. So each user has their own cell that's updated on a millisecond basis. And so each user has unique PRB, physical resource block assigned. You're able to reuse those in other parts of the building or venue. That enables reuse of 3 to 4x what you would get from a conventional system. And also it eases deployment, makes it much simpler to deploy and optimize that network. And as it turns out, it also greatly reduces the cost per square foot. But the point is that this is a 5G architecture that's available today on 4G and will assist in the evolution to 5G. And so as we evolve these networks from 4G to 5G, remember the key points for especially the physical plant are optimization, virtualization, and densification. Thank you.
Thank you, Ray. The next presenter is Mr. Jean-Pierre Bienaimé. He is Secretary General of 5G IA.
Thank you, Brito. Just some words about 4G LTE connections worldwide. In mid-May, we have passed the 3 billion figure, LTE connections. And what is interesting is that new markets, new emerging markets are taking the first ranks. Of course, China and USA take the first rank, but also India, Indonesia, Brazil are becoming a high number of LTE customers. We are speaking here of evolution, and from LTE-Advanced to gigabit LTE, still within LTE, but with a strong evolution. Indeed, we can observe now a strong decrease in LTE-A network, LTE-Advanced network launches. Let's not forget that LTE-Advanced is the real 4G, corresponding to the IMT-Advanced of the ITU. But definitely, there is a strong rise now in LTE-Advanced Pro launches, which is the last developments of LTE, release 13, with 5 carrier aggregation to boost the peak downlink speeds, and we can observe now up to 450 megabits, and support also for LTE unlicensed and LTE licensed assisted access. Growing global trial deployments for gigabit LTE. Gigabit LTE can be this evolution of LTE-Advanced Pro, and operators such as AT&T, Telstra, Sprint have developed these connection speeds peaks at 1 gigabits. And thanks to the progressive release of new spectrum for LTE, these operators are increasingly embarking in these carrier aggregation to boost download speeds. Let's pass now to our 5G PPP architecture recommendations through our 2 subsequent white papers on architecture. The second one updated, having been released recently in December, January, and based on the final works of our phase 1 projects, 5G PPP projects that have established a pre-standardization consensus on areas ranging from physical layer to overall architecture, network management, and software networks, and that strongly contributed to the progress in standards, notably towards 3GPP. And you can see here the various projects that contributed to this architecture white paper. Some principles, of course, it's a relatively complex 140 pages document that my colleagues have realized, and that is on our website, but I will just highlight some features. 5G system aims indeed at providing a flexible network architecture in enabling new business cases, supporting vertical industries, and definitely network slicing emerges as a promising future-proof framework and needs to be designed from an end-to-end perspective spanning over various technology domains such as core network, transport, access networks, and administrative also domain serving various mobile network operators, including management and orchestration functions. Security architecture shall be natively integrated and also satisfying the requirements of services and applications pertaining to safety critical use cases. The vision of the network slicing will therefore satisfy the demand of vertical sectors that request dedicated telecom services by providing customer-facing on-demand network slice requirements to operators as depicted in this figure. It's another figure also coming from the white paper explaining that by 2020, a 5G network of the future will involve the integration of several cross-domain networks, and the 5G systems will be built to enable logical network slices across multiple domain and technologies to create these tenant service-specific networks. So while legacy systems, namely 4G mobile networks, hosted multiple telco services, MBB, voice, SMS, on the same mobile network architecture with a certain monolithic elements. On the contrary, network slicing aims for building dedicated logical networks that exhibit functional architectures customized to the respective telco services, such as the MBB, V2X, URLLC, and MMTC, and so on. So 5G architecture decouples software-based network functions from the underlying infrastructure resources and combining, for instance, multiplexing functions with NFV SDN and adding flexibility. My colleagues have widely commented, including also the keynote speaker of Ericsson, the migration paths. This represents, I will not detail, but this represents the short-term migration paths, mainly short-term. Why? Because it's mainly based on Release 15, the first non-standalone being Release 15 that has been defined in December. Release 15 second part with option 2, which will be released mid of this year. Towards the Release 15, but late drops that will be defined by March 19. We can see here, for instance, there are other ones, but 3 scenarios. The first option, non-standalone 3X towards the non-standalone MBB and URLLC that supports network slicing, the 7X. Also the option 4 and the option 2 directly going to the option 4. We can quote that operators such as Verizon, AT&T, Docomo, Europe being the option 3X, China Mobile, for instance, T-Mobile, option 2. As Europe, they are mainly option 3X, but there are still uncertainties in Europe for the moment between 3X and 2. My last slide. Could you conclude, please? Last slide, yes. Europe actively preparing, it will be perhaps one of the questions, preparing 5G and fully monetizing 4G. So definitely operators have begun test multiplied partnerships. TIM, Orange, Telefonica. Verticals also are involved. But let's say 2020 will be the likely launch period, and we will have the opportunity at the question to detail. Thank you.
Thank you. We have time for questions from the audience. Some question? No? Oh, please.
Hi, Chris Nickel from ACG Research. My question is really for the panel. What I've heard from a lot of operators about when 5G is available, and I think the comment was made that 5G will appear in 2020. Can we have a definition of what do you mean by appears? Is this 5G commercialization? And if it is, does that represent 30% of your sites or 50% or 10 sites. So when you say 5G appears, could you just define what that means, for users in particular? Thank you.
I want to take that one.
Yeah, thank you for your question. When I say 5G appears, 5G is initially launched, so regardless of the coverage, 30% or 50%. So anyway, the 5G is initially launched. That means the 5G appears, I said.
Even one site is launched.
I don't think so. Yeah.
Yeah, not being an operator, I think there's various views on that, but certainly you'll see the 5G elements starting to arrive this year. With 5G core, new radio, and as I think T-Mobile have stated, they're going to launch 5G spectrum with 4G LTE type services. So I think initially it's all about just giving more bandwidth to the user, and then the rest of the elements will start to appear. But given the standards are not, as I think said earlier, that the standards are still not frozen, it's still going to be a while before we see a full 5G compliant network out there.
Yeah, just to add to that, from our viewpoint, Samsung viewpoint, it will be launched this year, right? It will be launched this year. I think now the question here is that the widespread adoption of it clearly depends on the handsets and terminal. What type of endpoints would that be? I think that would eventually dictate how widespread it would be utilized.
For Jean-Pierre, it looked from your timeline there that many countries in developed countries in Europe are more conservative in the rollout of 5G than North America, parts of Asia that we've discussed today. And I was just wondering your assessment as to why that's the case.
I think we can. Thank you for the question. I have a quotation. This prolonges my last slide. I have a quotation from a recent quotation from the CEO of BT, for instance, who said, 5G will get its time, but we need to make sure we get the most out of 4G. We need to ensure we actually get an ROI out of the 4G networks while also building a business case for 5G. So I think definitely Europe is preparing with trials, is preparing for 5G, and our pan-European trials roadmap, as presented by Didier and also Colin earlier, is here to accompany the most efficiently possible these trials. But perhaps they will be benefiting from the full standardization, and as it was said by Colin, there is a sort of lead time between the definition of a standard and the deployment, which is necessary. So I think it's the reason why I had this short-term path with release 15, because deployment of full release 16 will be later, and full deployment of release 15, including quite interesting functions like URLC and network slicing, will be in 2020, full in 2020. So I think this is more the behavior of European operators, although some Nordic operators, such as Telia, for instance, will be forerunners. Or also Swisscom announced that they will launch also early. So we will have also some forerunners in Europe, but mostly this will be this function. In my previous company at Orange, we said we prefer not to be necessarily the first to launch, but to launch first time right. That is to say, to deliver the full customer promise.
Okay, we have time for one more question.
Okay, it's a compounded question, though.
Okay.
First part, I would like to hear from all the panelists. And a gap analysis. Technically, what do you think is the gap that remains to be filled from what Release 15 is delivering between that and what they set out as the KPI, so to speak, of 5G? And do you think Release 16 is going to fill that gap? And the other part is, we all know that the success of 5G will require not just a technical success, but also business success. So what do you expect when, and most likely in what case, would be a shining star case that would qualify a bit as what Colin, I don't know if he's still in the room, has said, delivering on the promises of 5G? I hope this question is not too convoluted, but
please. That's a tough couple of questions. You know, I think it's hard to say between the gaps between Release 15, Release 16, you know, until, you know, you start to see what can be physically implemented and, you know, what's going to come along. Then I sort of defer that one to other members of the panel. But, you know, on the second question, I think, you know, I think the most important thing is for 5G to be successful, the operators have got to be profitable. And, you know, so it comes down to open interfaces, virtualization, standard hardware, changing the cost models of how some of these networks will be built. And, you know, the whole thing about, you know, everything going through a central core, for instance, you know, that's a 20-year-old architecture that's essentially out there. And, you know, and it really forces this, you know, the whole way the mainframe went to distributed computing. And I think distributed computing in 5G networks is going to be the key to some of the success of, you know, how networks are deployed, how networks are densified, and the success to the operators. So flexibility, decentralization, and open interfaces, I think, are a lot of the business aspects.
Okay, it's a very interesting question, but we have time only for more.
Yeah,
one
let me
answer,
just add to it. I mean, another area I think which is also important. I mean, purely from the radio standpoint and spectrum is in terms of the coexistence of LTE and 5G. The simplistic deployment configuration is you reserve certain channels and that is how it coexists. But I don't think that it would be very efficient. I think is that there's going to be a lot of work that is needed in the standards in terms of can you coexist in frequency and time domain? Can you exist all the way down to TTI basis? I mean, can you coexist? So I think you have to look at it. I think another area also is equally important is that now you're bringing in all these different numerologies and waveforms. How effectively can you coexist and what type of spacing is necessary? The whole goal here is can I have LTE and as well as NR coexist in the same band, same channel, at the same time be spectrally efficient?
Okay. Thank you very much. The session is finished. Thank you very much.